A very good afternoon, everyone. I hope that you all are able to hear me and also you're doing well. So I hope that you had a wonderful break as per your mid-semester break. So I welcome you back to week 9 of semester 2. And as you must have noticed, the time is flying away very, very fast, and we have reached to the after the mid of the semester. Now, for this week, there are a few things that we will be doing. As usual, we will be going over our to-do list for week 9. So if you would generally have a look at it, so you are to attend the Zoom-based lecture class, which is this particular class. You also have to attempt your lecture-based quiz, which you may find right underneath week 9 section of the Moodle show. Moreover, you have tutorial questions to attempt and submit it in the forum. Again, the submission to the forum does not carry any mark towards your coursework, but it would be beneficial for you in future, especially in terms of revising for your final exam. Moreover, your Zoom-based lab and tutorial class is scheduled on Thursday. So we will be definitely going over them. And also in this week's lab class, we will be looking at use case diagrams. Okay, now use case diagrams are pretty complicated because you need to understand the procedures and the steps involved in drawing up a use case diagram. We'll try to make it interesting in Thursday's class and learn them accordingly. And moreover, your mid-semester exam marks, they have been released, and you may have a look at your marks in your gradebook. Okay, and how do you do that? So you'll go on to grades. When you click on grades, you will be able to view your grade books. Okay, and do go and have a look at the review of your attempts. Now, for your short answer questions, what I have done is wherever I feel that you have not deserved full marks or where you have answered incorrectly, I have stated down the reasons in the comments. So if you feel that you deserve some more marks here and there, feel free to drop me an email or also drop me a message on Moodle. I'll have a look at them and I will try to reconsider to the best of my abilities to see whether you actually deserve any more marks or not. But I will mention it. I have marked your mid-semester exams very slowly and steadily to ensure that there are no errors while marking. All right, so that's for reminders for week 9. Okay, another reminder, please. I hope that you are already working on your major project. This is the 20th of September. Your major project is due on the 31st of October. So you have close to about, there's 31 days in October plus another 10 days. So you have 41 days remaining. So please get your assessments submitted well before time so that you do not have additional pressure and tension while you're preparing for your not mid-semester, while you're preparing for your final examinations. Okay, yeah, so any questions, any queries from anyone? All right, any questions, any queries from anyone?
So, any idea when the university will be opening again?
Okay, I understand. Thank you, Janesh, for your question. I understand the enthusiasm. Now, at the moment, last week Friday, I think the government had released a statement over the media that universities will be opening on the 4th of October. Now, while the government has gone around making that announcement, that brings good news to us that we might be going into face-to-face mode from the 4th of October. However, the university is completely mum into this. In other words, what they have not released any, the university has not released any form of news and statement as to when the FNU campuses will be opening up. Now, if you have been looking at your student emails, Lotoka campus was one of the campuses which was infected by COVID-19. Okay, so the campus is in the process of being sterilized, and fumigated. So that is another process. However, at the moment, there's no news from the university. So I would suggest keep in tab with your student emails, or even I will let you know if we are opening up. But so far, there's no news. Okay, so If there's no use, we'll keep on operating as it is. It's also a bit of procedures as well, because if we would go onto a face-to-face mode, we'll have to maintain a certain amount of distances while we are in classes. Moreover, each and every student who would be entering the campuses, they would need to be fully vaccinated or vaccinated rather. Okay, so those are some of the things that would be taken into consideration. So yeah, so far no news from the university. Obviously they'll have to do a lot of groundwork. The campuses, they haven't been opened up for quite some time, so it must be collected with dust, leaves, and dirt all around. So that needs to be cleaned up. The devices needs to be well serviced, air conditions, the labs, computers, and stuff. Yeah, so there's a lot of work yet to be done. So as news come in, I will definitely let you know. Any other questions, anyone? All good? Okay. Last call for any questions. If there's no questions, let's begin with our lecture notes. We have quite a number of slides to go over. I think there's about 42 or 41 slides, so we'll try to go over them. And yeah. All right. No questions, let us continue. Now, today's topic for week 9 lecture is on development strategies. Now, what kind of development strategies are we looking at? We are looking at development strategies while coming up with an information system. Now, information system, it is a collection of people, procedure, hardware, software, and communication. So when you combine all these elements, you form up a information system. Where it is used, how it is used in separate organizations, how or why it is used, so that you have an efficient flow of data which assists in adequate decision making throughout the life cycle of an organization. Now, why is information important? Information allows organizations to make decisions. What kind of decisions? Generally, all those decisions that tend to derive in making more revenue for an organization, henceforth more profit level. Now, which organizations would end up using information systems? Any organization can use an information system considering the size of an organization. Now, some organizations, they do not have for example, if we have small organizations here in Fiji, they do not have an information system, but they do have a recording system, which could be somewhat sort of counted as a transaction processing system. So a transaction processing system is an information system. Okay, so yeah, so those are the things that we'll be looking at in today's class in terms of what are some of the strategies that an organization can take up when creating an information system. So learning outcomes for the chapter or for the lecture is, we will first of all go and describe the concept of software as a service. The term software as a service, or SaaS, SaaS, it is driven from the turmoils, or it is driven from the environment of cloud computing. We'll also go and define what is Web 2.0. By the way, we are living in the environment of Web 3.0. But we will go and define what Web 2.0 is and what is cloud computing. Now, why Web 2.0 and why not Web 3.0? Because Web 2.0 is where these information systems started to flourish. Explain software acquisition alternatives. When we talk about acquisition, we're talking about how do we achieve something. Okay, so what are some of the software acquisition alternatives? And those alternatives are traditional and web-based software development strategies. We also go around and describing the various form of outsourcing options. So we have quite different types of outsourcing options. We have offshore, we have inshore rather. Okay, so these are the two different types of outsourcing options, and what are the roles of the application service providers in the concepts of outsourcing. Furthermore, we'll also go around and look at the advantages and disadvantages of in-house software development. Okay, when we talk about in-house software development, we're generally looking at the concept whereby the organization goes around to create the information system within the organization. So what they will do is they will need to have few sets of experts, mostly programmers, system analysts, and other range of people who would go around developing the software or the information system within the organization. We'll also discuss on cost benefit analysis and financial analysis tools. Now with CBA and FAT, what we'll be doing is CBA, by the way, is cost benefit analysis. FAT is financial analysis tools. We'll look at them theoretically first, and with it comes calculations. Of the calculation part, we will begin off in 2 weeks time, because this week, next week, week 9 and 10, I'm dedicating it towards use case. Thereafter, we'll go around looking at CBA and FAT. We'll also describe and differentiate between request for proposal and request for quotation, and we'll describe the system requirements documents and explain the transition from systems analysis to systems design. The last phase, transition, that means how or what work takes place when you analyze a information system and then you go around designing it. Now, analysis comes first, followed by design. Once you analyze, then you have a system requirements list. Through the requirements and through all the things that an organization needs, you end up designing a system. Now, designing and building are two different things altogether. Designing is when you have a logical design. Logical design, basically a paper-based or software-driven design. In system implementation is where you actually build the system, or is where you actually get the actual thing done. Okay, so we'll look at the transition between these two. Okay, slide number 4. Let me go and give my slide in full mode. Okay, development strategies overview. Earlier, certain work functions in the company required development of software by in-house efforts, employing the services of external entities. Now, the word earlier means in previous days. Now, in previous days, if an organization would want to come up with a software or an information system, so they would do either of the two things. Firstly, they will have or make an attempt to build the software in-house or within the organization, or what they will do is they will go and acquire services of an external entity. External entity, that means you are trying to get the software hired or get the software developed by another organization. Okay, so those were the only two methods. However, today organizations have following choices for software acquisition. So the organizations these days, with the implementation of Web 2.0 and cloud computing, these options have come up. If you need a software, you have an application service provider. So an application service provider is basically a provider of a software that gives you the software for a specific amount of fee. For instance, if I am using, let's say, Microsoft Word, okay, so if I want to use Microsoft Word, I need to purchase it off from somewhere. Okay, if I want to use it online, I have to pay for the subscription. Okay, so these are the work of an application service provider. Now, another way in which you can quickly differentiate between the two is you have ISP, you have ISP. ISP is Internet Service Provider. It's an organization that provides you with internet services. ASP is an application service provider. It's an organization that provides you with a software for a specific amount of fee. The second option that many organizations can do to have software acquisition is web-hosted software options. Now, this is very common. Many organizations are opting for web-hosted. Why web-hosted? Why not buying the software? It's just because of this. When you actually have a software that is web-hosted, that means over a browser, you're using, let's say, Adobe Photoshop. So the advantage is when the newer version of the software comes up, you do not need to entirely spend a large amount of money to purchase the entire software. Okay. However, if you're using web-based, you can pay the same subscription fee that you were paying, and the new version of software comes in. Firms that offer enterprise-wide software solutions. Okay, so the third option is you can hire firms that offer a enterprise-wide software solution. That means they provide a software solution whereby it handles the work of a transaction processing system. It can also handle the work of a decision support system. By the way, transaction processing system, it tracks day-to-day activities. DSS, or decision support system, what it does, it provides information in such a way that enables the middle level managers to make their decisions very, very quickly. And then you have a services of a ERS. Now, ERS is a specific type of DSS that allows the top level managers to have decision made for strategic planning. So those are the things that an enterprise-wide software would give to an organization. So that means entire thing in one bundled application. So these are the three set of options an organization takes or can take if they need a new software to manage things within their organization. Now, if we compare previously, build the software in-house or employ an external entity to build the software for you. Nowadays, you have a application service provider that provides you with the service by specific fee. You have a web hosted software option whereby you have the software available on the web. And finally, you can hire a firm or get software off a firm that provides you with a enterprise-wide support. So selecting the best development part is an important decision. So now the decision depends basically on the organization, okay, whether they want to go with the earlier version of doing things, the old version, or they want to do what is happening today. So like I mentioned, it depends on the organization. Now, what we'll do from here is we'll start breaking things down, and then we'll look at what are the advantages and disadvantages, what are the features, what are the prospects of choosing either of these options. Now, the impact of the internet. Now, with the internet came in software as a service. Now, remember, with the use of the internet also came in cloud computing. Now, have you used cloud computing? Anyone? Have you ever used any form of cloud computing services? Let's have some people answering. No one has used any of the cloud computing services? Anyone has used Google Drive? I think so. Okay.
Yes, sir.
Yes. Okay. So Google Drive is a cloud computing service. If you are using Gmail, that's also a cloud computing service. Now, how does Gmail becomes a cloud computing service? Now, what happens is your email is stored not in your physical computers, but it is stored somewhere in a server in some other country. Okay, so what you're doing is you're accessing that server from your homes to the use of internet services. So that forms cloud computing. So anything that goes out of your physical computing system, out of your house, and is stored elsewhere, and you're accessing it on daily basis, that is an example of cloud computing. Now, with cloud computing comes software as a service. Now, this is one of the key features of cloud computing. Why? Because it provides you software for a specific amount of fee. Now, software deployment model that hosts an application as a service provided to customers over the internet reduces the customer's need for software maintenance, operation, and support. Now, software as a service, it provides you with the software over the web for a specific amount of fee. Now, many organizations, they prefer this. Why? Because it reduces the customer's need for software maintenance. If you have a software which you use it in-house and it is built in-house, so there's a likely chance every now and then you need to maintain something in the software. And maintaining would mean even updating the software. Maintaining would mean fixing up bugs, fixing up errors. Okay, you need someone to operate it for you. So even though you are using it, there would be a set of IT guys who will go and check to see every now and then that things are running as per the expected outcome. Moreover, you need additional support for these kind of softwares. So when you're hosting it online and using it as a SaaS, software as a service, none of this is required. All you do is you are the user. Okay. For example, I'll give you a very simple example. Now let's treat Facebook as a software. Do you maintain anything? No, you don't. You just use it. Do you ensure that every now and then? Let's make it like this: when you're using Facebook, you know that everything is working fine, provided you have internet connection. Everything is working fine. You post a picture, you have that kind of feedback in your mind. Okay, everything will go well. My picture will get posted unless and until there's an internet disruption. So you're able to do things without any issues. Likewise, same thing here. Now, the traditional versus the web-based development. Now, with the impact of the internet, we'll go and discuss how things move from the traditional point of view to a web-based. Now, web-based is the modern era, okay? Actually, you can say it's a semi-modern era. Why semi-modern era? Because with the introduction of Web 3.0, everything from web-based is going into mobile application-based, okay? So remember, Web 1.0 was very simple, okay? All you were doing was you were using certain softwares, you were using certain internet-based services to get things done. With Web 2.0, it allowed more collaboration, it introduced cloud computing. And Web 3.0, so you're mixing Web 1.0 plus Web 2.0, plus you have mobile communication coming in. Now, at the moment, we're just looking at traditional and web-based systems development. So the first one that you have is service-oriented architecture, a way of engineering systems in which reusable business functionality is provided by services through well-defined interfaces. Technically, not software architecture, but an architectural style. So software-oriented architecture, it is where the business functionality controls are provided by a software, and that software is basically interface-based software. When you talk about interface here, we're talking about user interfaces. So when you're using Microsoft Word, you're not writing down commands, okay? You're not writing down those commands. You're not writing down any foreign language. What you're doing is you are dragging your mouse pointer on the screen here and there, and you're performing some form of functionality. That is interfaces or user-based interfaces. Okay, so what software-oriented architecture does, it provides with a set of systems in which you can perform your business functionality through the use of a software over the web. Now, traditional development. System design is influenced by compatibility issues. Now, in the traditional method, so the system design that was done by, let's say, the IT professionals, so what they would do is they will try to get the design done influenced by compatibility issues. Compatibility means able to work together. So if they have machines, various machines, if they have various software, so the design will be influenced by whether the new software that is going to be designed would work with all the previous or existing systems or not. Now, systems are designed to run on local and wide area networks. So local network within the organization, wide area network is outside the organization. I'm talking about networks within the organization and outside the organization. So the design is again derived by these two factors. A system often utilizes internet links and resources. Development typically follows one of the three main parts. Important things here. So in traditional, whether it's done or performed in-house, purchase a software package with possible modifications. That means you're purchasing a software from someone and you're asking them to perform some form of modifications on them. And what you do is you bring in outside consultants. Now, the third point used to be very common in Fiji a few years back. Why? If you need to get a new software done within the organization, so you hire a consultant from overseas. So they would come in, they would charge they'll charge hundreds and thousands of dollars. They'll come and stay within the organization at your expenses. They will, you pay for their accommodation, you pay for their meals and everything. You ensure that they get the software done. So once they're done, they go back and return to their countries. So use of outside consultants, and it very much occurs in a lot of different industries here in Fiji at the moment. For example, let's have a look at this. You have these road engineering companies. You'll see not see, but you normally read over the media that consultants are brought over to survey and get things done here in Fiji and get the standard in place. You have things like this done in universities as well. You have things like this done in transport industries and even some of our government agencies or government platforms as well. So you hire a consultant, they will come in, they'll perform the work for you, and then you pay them something. Likewise, these three methods are used here in the traditional development method. Now, one thing about traditional development was scalability. What do you mean by scalability? Scalability is you are trying to ensure that the standard is maintained throughout the life cycle of a system. For instance, if your system was able to cater for 1,000 people right at the very beginning, and let's say if the numbers increase to, let's say, instead of 1,000, now you have 10,000 customers, your system should be able to attain, or your system should be able to perform with that number of users altogether. Okay, so scalability is affected by network limitations and constraints. So this was one of the issues, the major issues with the traditional development method. Now you must be thinking, how does that affect? Let's say you are running an e-commerce website. Now, initially you had planned for the website to have consistently about 1,000 people on the same time on the web using the system. Over time, your business has grown rather, and then now you have 20,000 people at once having or buying things off your website. Now, what will happen is with that much of traffic coming in, it's bound to slow your website. So you need to ensure your website is designed and accommodated in such a way that such things does not occur. There's no scalability issues. If your website is too slow, if it's not able to fulfill the demands of your customers on time, you'll end up losing customers. Now, came in web-based development. Now, web-based development systems are developed and delivered on the internet-based framework. This is pretty simple, I guess, and I think most of you should be able to understand it. It is where the entire system is delivered off the internet. Internet is a short form for internetwork. Internetwork means many different networks connected together. Now, how does that relate to what we're doing? When we are accessing Facebook, what we're doing is we are connecting to a network which is based somewhere in US. How do we connect it? Through the use of the cables that are running through the Pacific Ocean. Okay, so we are able to connect it in one way or the other. If you want to research more about it, do go over the web and see how Fiji connects to the internet. Now, treat the web as a platform rather than just a communication channel. So the web, the World Wide Web, is the platform where the software is basically used or begins from. Web-based systems are easily scalable and can run on multiple hardware environments. Now, this is where the advantage comes in, or the positive feedback come in the web-based systems. Traditional systems had a problem scalability issues. With web-based, is easily scalable. Why? Because you don't have a physical hardware controlling it from your location. You have someone, or you have a company which basically runs it for you. So just in case if the company is not able to provide you with that service, what you can do is you can pull out and engage with another company. Used for customer relationship management, order processing, and materials management. Treat software applications as services that are less dependent on desktop computing power and resources. Just like I mentioned earlier. So when you have a software, or if you have an information system that is web-based, actually you do not need to worry about the computing power of your computer system in-house. You do not need to worry about whatever resources you have in-house, because all of these hardware resources are provided by the ASP, application service provider. All you have to do is you have to pay for it and then you use it within the organization. Slide number 9. Now, web-based development requires additional layers called middleware to communicate with the existing software and legacy systems. Now, the middleware, what it does, okay, the definition is given there, connects dissimilar applications and enables them to communicate and exchange data. So the middleware rather, what it does, it is an intermediary software. So intermediary software is something that connects one software to the other. Now, in the case of an information system, so the ASP provides you with the software and here's you on the receiving end. So what the middleware does, it connects both of these and allows communication between the two of those platforms or two of those destinations. Let's say you've hired something from Microsoft Word. Let's say Microsoft Azure is an example of a ERP. So using Microsoft Azure, what you have done is you've connected your organization to Microsoft Azure. So what happens is basically there's a middleware that is connected and Microsoft Azure connects to the middleware, you connect to the middleware and communication takes place. Now, the next point is a critical point in web-based systems. Open more complex security issues that should be addressed. So what happens with you connecting over the web is you have a lot of security issues. Now, these security issues may be in terms of people who are working for the ASP or hackers who may intercept your data every now and then. However, you need to be very careful and you need to know this, that there are a lot of security procedures that are provided for you to have an information system run on web base. But you need people or you need right set of mind and eyes to actually read and understand the concept of how your data would be secured. Evolving trends, Web 2.0, cloud computing, and mobile devices. Web 2.0, second generation of the web that enables people to collaborate, interact, and share information much more effectively. Now, with Web 2.0, the major focus was collaboration, interaction, information to be passed on and shared more and more easily and effectively. By the way, if you look at Web 2.0, if you would study about it, Web 2.0 is the generation of the web that introduced social media. It is the generation of the web that introduced instant messaging. It is the generation of the web that introduced you sharing data from one location to the other very, very easily. Otherwise, in previous days, what you'll have to do is you'll have to print it out, fax it overseas, or what you will need to do is basically send it over through a postal envelope or so forth. I remember back when I was working for an organization back in about 2011 or so. So if we had to send documents overseas, we would use a fax machine to send it. So Web 2.0 was already there, it was already out there, but people were not so used to it. Okay, so over time when people came to use it, so why would you go on faxing things when you can just quickly send it over via an email? Or why do you need large scanning machines when you can take photographs off your phone and send it over? Okay, or you can have a small flatbed scanner somewhere which costs about $100 FJD, scan it to your computer system and send it over. So that becomes very, very easy. Okay, cloud computing, online software in which applications and services are accessed and used through an internet connection. Mobile devices, smartphones, tablets, and other computing devices that are not permanently tethered to a desktop. The word tethered means connected. Okay, so cloud computing, I think I've already explained what cloud computing is, services over the web. Mobile devices. Now, mobile devices, I hope you also know what mobile devices are. Anything that is portable, any electronic device that performs a work of a computer system, but is portable. You have smartphones, you have tablets. Now, can I get some more examples from you? What all else would come under mobile devices? You have smartphones, you have tablets. Anything else you can think of? iPad, iPods, okay, those music players, are they mobile devices? Yes, they are. How? They allow you to connect to the internet. They allow you to have processing capabilities of a computer system. Anything else?
Smartwatches.
Smartwatches, yes, smartwatches is an also example of a mobile device. Thank you, Ronish. What else? You know what PDAs are? Personal digital assistants. Okay. Now those are also, do search over them, what they are. They also act like a mobile device or very much similar to a phone. So those are also mobile devices. Even your laptops are mobile devices. Why? It's mobile, you can carry them around. Okay, it's portable. So laptops itself can be considered as a mobile device. You have not with the net with the laptop, you also have web books. You have yeah, web books. You know what web books are? Very much similar to a laptop, but very small in size. Okay, you have ebook devices. Kindle is an example of an ebook devices. Okay, so they also are of a size of a tablet. So these are also some types of mobile devices that came up, and eventually more and more mobile devices would be coming up over a long time, or sorry, within a few years of time. Now, just recently, Facebook released smart glasses. Those are also mobile devices. Smart glasses, they connect to the internet. They allow you to perform certain things. Okay, so mobile devices as well. Next thing that we'll be looking in software development is outsourcing. Outsourcing is the transfer of information system development or operation or maintenance to an outside firm. So what happens in outsourcing is basically you want to develop a software, so you do not have sufficient amount of resources to get it done within the organization. Now, resources here could mean in terms of people, it could mean in terms of technology, it could mean even in terms of finances. Building a software in-house is more expensive than getting it done by somebody else. Okay, so just because of limited resources, you hire an outside firm to do it for you. So that concept is called outsourcing. The growth of outsourcing. So service provider, application service provider, they provide outsourcing solutions. In other words, they provide you with the software or they provide you with the service. It delivers a software application or access to an application by charging a usage or subscription fee. So ASP, they build the software for you as per your specifications, or you can use an existing software that they have for some certain amount of subscription fee. And then you have internet business service, also called as managed hosting, provide web-based support for transactions. Now you'll notice that very much common in India, India and China. Basically, they have call centers. So most of those call centers, they provide an external service whereby they provide support for the transactions. Okay, so these are internet-based services or IBS in simple terms. Now, outsourcing fees. So there are three types of fees in outsourcing. You have a fixed fee model, uses a set fee based on a specified level of service, and user support. So this is like a fee that you pay most likely on an annual basis. Now the annual basis may be in terms of yearly, or it can be monthly as well. Okay, so you pay a certain fee for a certain level of service and a certain level of support. You have subscription model, has a variable fee based on the number of users or workstations that have access to the application. Now, subscription model, now this is the most common out of all the three. Why? Because the thing is, your number of users is generally vary, okay, within an organization. So if you would compare subscription fee and fixed fee, subscription fee would be a bit more cheaper compared to the fixed fee. So organizations would go with the subscription model. Just in case if your number of users increase, then you can go back to the ASP, application service provider, and they will increase the fee and give you additional number of services for the additional user. A very good example is what we have here in FNU. The Microsoft Word that you're using is a fully licensed version by Microsoft, okay? And FNU pays a subscription model fee on it, and it's paid on the number of users within the organization. In other words, the number of devices that we have, it's paid for it. Users model or transaction model charges a variable fee based on the volume of transactions or operations performed by the application. So this is more likely on the number of transactions that you have. perform or the number of transactions that you do. I would say if you would have a look at the users model is very much similar to what we had previously with the internet connection when Connect used to be the leading internet provider. So they would provide you with a post-pay system. Okay, so the amount that you use, you are charged for it. Very similar here, users model or transaction model. Now, outsourcing issues and concerns. Now, mission critical IT systems. Mission critical IT systems, something that is a must or something that is a critical thing within the organization are outsourced if the result is cost attractive and reliable business solution. So you would only go and outsource your MCIT systems provided they're cost attractive. That means the cost it incurs within the organization compared to what it is done outsourcing. If the outsourcing is the cheaper option, then you would go with outsourcing your mission critical IT system and reliable business solution. Overseas outsourcing can raise issues with control, culture, communication, and security. Now, these are the common things with offshore outsourcing. Offshore outsourcing is when you are trying to outsource the service to a organization outside your country. Okay, for example, I'm here in Fiji. If I run an organization, I am outsourcing it to a company in Australia. So the issue is control. Now you have very little control over the system if you have outsourced things. Why? Because the ASP basically does all the controlling end. There would be culture or communication lapse. Okay, for example, if a person in Fiji may find it a bit difficult to communicate with the person in the States. Why? Because of the intimidation of speaking English properly, or probably a person here in Fiji would find it very difficult to speak someone in, let's say, South Africa. Okay, the communication lapse, and also security. Security in terms of if you have your mission critical system on web-based, you always have that fear in you that something might go wrong or your data may get leaked. Reviewing the outsourced firm's history and financial condition is vital. Now, so if you want to ensure that you are choosing a correct outsourcing company, you can view their history, or simple terms over the web is you can always go and check their reviews. Okay, outsourcing clients can be affected by mergers and acquisitions. In other words, if you are, let's say, outsourcing your software, okay, and let's say a new company buys the company that you'd outsource with. So with the merger or acquisition means a new company takes over the existing company. So if it takes over, what happens is you may be affected. Your fees may go up, or there would be depreciation in the service because the management changes overall. And then the employee job security is a major concern. So when you start outsourcing, some of the employees in your organization may be slacked off, or your organization may be right-sized. Okay, when I say right-sized, that means you may have to go and hire or fire people because of that. Offshore outsourcing is also called as global outsourcing, shifting IT development, support, and operations to other countries. Okay, we've talked about this. The reasons for you to perform a offshore outsourcing or global outsourcing is lower bottom line costs. A lower bottom line cost would mean, okay, you have a company's income, and after all expenses have been deducted from a revenue, you are left with something, certain amount. Now that amount is called profit. So if you have a basis where you make more profit and reduced expenses, then you go over with offshore outsourcing. To put it simple terms, the reason lower bottom line cost would mean whereby your expenses decrease drastically, okay, compared to your revenues, then you go with offshore outsourcing. Risks and concerns, impact on the economy. Okay, so if there is this would be more likely a concern, because when you outsource things, the company overseas, they are the ones who are earning. So that indirectly, it will have, not indirectly, but directly, it will have an impact on the economy of the country in which you are in. Why? Because you are paying overseas. So the money circulates in their country and not in our country. Project control, you have little control over things. Why? Because it's completely outsourced in another country. And then security issues, which we had gone over. In-house software development options. Software development options, you develop your own system, purchase, specifically customize and implement a software package. Most important consideration is the total cost of ownership. Companies can develop user applications based on commercial software package. Okay, now in-house development, now we have talked about it, building a system within the organization, or what you can do is you can purchase and then you can possibly get it a bit customized by the vendor. And the most important thing when you are considering while developing a software in-house is the total cost of ownership. That means how much does it actually cost you to build a software or build a information system. Generally, if your total cost of ownership is very, very low compared to the other options that you have available, so the other option is you completely you're outsourcing it, okay, or you actually having a web-based option, okay. Now, if it's still lower than the other two options, then you can build your software in-house. Companies can develop user applications based on commercial software packages. What it simply means is some companies, what they can do is they can buy a commercial software. These are ready-made software that organizations would sell. For example, Bonware would sell. So you bring in that software, implement it within your organization, and adjust things accordingly to the software. Now, remember, when you buy a software off the shelf, okay, there's a likely chance you may not go and modify things because you may not have that much of resources to modify. So when you are not able to modify, you bring in the software within the organization and start adjusting things, start adjusting the processes and the transactions as per the demands of the software. In-house software development, make or buy decision. It refers to the choice between developing and purchasing. A company's IT department makes, builds, and develops in-house software. A software package is obtained from a vendor or an application service provider. So to make or buy, which decision you take basically depends on the organization's resources. If you have resources like you have the finances, you have the people, you have good management people within the organization, then you can always go ahead with the provided skills and try to make the software. Now, if you don't have the resources, so it's best you actually go and purchase a software from a vendor or from an application service provider. And if there are any tweaks needed, you can get it done directly by them. Software package, okay, obtained from a vendor or application service provider. Software vendors, they develop software for sale. Okay, so software package is basically a software that is sold by a vendor or an application service provider. So software vendors are those who develop the software and they sell it. Value-added reseller, or VAR, enhances a commercial package by adding custom features and configuring it for a particular industry. So VAR, what they do is you have a software that software vendors sell, and they bring it in within their organization, or they bring it in and they add and tweak features here and there and then resell them. That's why it's called value-added reseller. Okay, let me give an example. Let's say I buy a software and the software is called ABC software. And when I try using the software ABC, at the very first glance, I know that this will not fit in my organization. So let's say I buy it from an organization called Bonwell, and I take it to an organization called VT Solutions, and I give it to them, and I tell them, okay, these are the things that are wrong. Okay, I need it to be fixed. They fix it and they resell it to me, or they fix it and they charge me a specific amount of fee. So over time, what VT Solution does, once they actually see that, okay, a lot of people are coming and demanding for the same thing. So what they do is they will go and buy the software from Bonewell. They will add in all the tweaks that they have accumulated, and then they will resell. So let's say they buy it from Bonewell for $500. They retweak it, add value to it, and they sell it for about $1,000. So that is the difference between a software vendor and a value-added reseller. Horizontal and vertical application. Horizontal application, now these applications are made for different types of organizations, okay, and can be used by different types of organizations. For example, a payroll system. can be used by any type of organization. On the other hand, you have a vertical application, which are generally made and used by specific type of businesses. Example, medical, example, architectural. Okay, so with architectural, you have the CAD software, computer aided design. Now, CAD software cannot be used by an accounting firm, so specific to a particular industry or a type of a business. Midsemester exam question, by the way. Now, reasons for in-house development and reasons for purchasing software package. Now, we have discussed this table already in the previous slides. Okay, so I will skip this slide, but what I would suggest is you can note down slide 18 somewhere, and just in case if a question comes in, which one is better, yes or no, and give a reason, you can use this summarized version of it. Developing software in-house, okay? So satisfies unique business requirements, not possible with standard commercial software packages, minimizes changes in business procedures and policies. Installing a new software almost always requires some degree of change in how our organization does business. Now, point one, satisfies unique business requirements. What it simply means is when you're building in the software in-house, you know what your requirements are, you know what all the issues are in the organization, and you can fix it with the software that you're going to develop. Now, look at the last point. If you're installing a software package, that means you're buying the software off the shelf from an organization, and then you're trying to implement it within the organization, you'll have to start changing the operation of the organization based on the new software that you're purchasing. Whereas if you're building it in-house, it becomes way more easy because you do not have to adjust to new processes. As per the software, you'll actually design your system according to the current processes. Meets constraints of existing systems. Any new software installed must work with existing systems. So when you build in your software in-house, you already have the old system, which you will now call it as a legacy system. So your legacy system and the new system, it should be able to collaborate. It should be able to work together. So when you're building it in-house, you can do that more easily. Meets constraints of existing technology. We have talked about this. Technology here would mean is your hardware and the physical components. So your physical components, let's say if you are building a new system, you have an old computer, you can still make it work when you're building it in-house. If you have if you buy a new software directly and try to implement within the organization, there's a likely chance you have to purchase a completely new set of hardware technologies. Now, develops internal resources and capabilities. Companies can develop and train IT staff who understand the organization's business functions and information support needs. What happens here is when you are building in the software in-house, you are not only getting a new software, but you're getting quite a new set of skills for the individuals working within the organization. So in future, another project comes in, these people can also work well and get things done. Purchasing a software. So let's go and compare. Now, lower costs. A software package is less expensive than the one developed in-house. How and why? When you're developing in a new software in-house, you might need to hire new people. You might need to go and purchase some devices. You might need to go and train your staffs. Okay, sometimes getting them certifications, sometimes sending them abroad to go and learn new things. Okay, so when you purchase it, it becomes easy, your cost decreases. Now, second point, requires less time to implement. Packages have already been designed, programmed, and tested and documented. Now, this is the plus point, and this is where many times organizations go with packaged with software packages. Why? Because when you're building in a new software in-house, you have to go through the entire SDLC process. Sometimes it takes months, sometimes it may take years to get the project done. However, when you're purchasing it off the shelf, today you decide you want to get the software, you can get it in, get it installed, tomorrow you are up and running. Okay. Proven reliability and performance benchmarks. Major problems would have been detected and corrected by the vendor. In other words, in-house softwares, okay, when you're building it yourself, somewhere in the middle of the operation phase, you find out that something is wrong, then you have to go and do things. With the packaged softwares, Okay, now those things have already been detected and corrected by the vendor, so you don't need to worry about those things. Requires less technical development staff. Companies can reduce the number of programmers and systems analysis on the IT staff. So like I mentioned earlier, the resources, okay, the resources part, you also have your technical staff coming in. So you don't need a highly technical staff whom you need to pay about $70,000 to $80,000 per year. Sometimes you need more than one staff also. So you don't need them, okay? You don't need two technical staff. People who are just basic ground level support staff can also work with a software package. Feature upgrades provided by the vendor. Improvements and enhancements are included in regular updates. For instance, if you have a licensed version of Windows 10, do you need to go and develop or program it yourself? No, you don't need to. You've already paid for it. So what do? Just run the updates, get the patches coming in, and get it uploaded and installed in your computer system. Same thing here. Input from other companies. Users of other companies can be contacted to obtain the input and opinions. So when you're purchasing an in-house software, you can get opinion from other companies. At the same time, when you're using it and something goes wrong, you have technical support provided by the vendor, one, or you can always go and consult some other companies who are already using it. Now, customizing a software package. Purchase a basic package that vendors will customize to suit project requirements. Negotiate directly with the software vendor to make enhancements to meet project needs by paying for the changes. Purchase the package and make project-specific modifications. Ensure modifications are permissible under the terms of the software license. Now, what it is talking here is this. Let's say you are planning to buy a software package, but what happens, you see that some of the things do not meet the requirements of the organization. So what you do is you can always go and consult the vendor, and if agreed, you can go and tweak a few things here and there and make enhancements to meet the needs of your organization. Creating user applications. Okay, so when you are creating user applications, so user application utilizes standard business software. User interface enables effective interaction with the application. So with the user interface, it allows you to easily interact with the application, just like you're doing with Microsoft Word and other types of applications that you use. Service desk or information center provides user support. Scheme generators and report generators allow users to design their own data entry forms and reports. Appropriate controls must be provided to ensure data security and integrity. Okay, so these are some of the things that you need to ensure to have it included when you are creating your own software in-house. So when you're developing a system in-house comes in the roles of a system analyst. So based on the decisions taken by the organization in the systems development process, so current and future needs are considered. So not only you are considering the needs of the current day, but you also have to think about next few years as well. Okay. Evaluation and selection of alternatives is a complicated process. Forecasting actual costs is difficult. So what happens, what the sentence means over here is, when you're forecasting data, when you forecast, it means you're looking at future. When you're looking at future, you also need to consider the future revenue and the future costs. So that is a difficult thing to do because sometimes things may not go as you plan. For instance, 2 years back, nobody thought there would be something like COVID-19 coming in and affecting the entire economy, affecting all the businesses. Would they? No, they didn't. So if you are considering future or forecasting costs, you need to have a very good look at your evaluation and selection processes. Now, evaluation and selection team selects the hardware and software. And includes system analysis and the users, ensures that critical factors are not overlooked and that a sound choice is made. Yeah, financial analysis tools. Now, these are some of the things that we will be working on with calculation. You have payback analysis. That means, in simple terms, payback analysis is within how many years the system will start generating revenue for the organization and cover up all the costs. Return on investment is, that means percentage rate that percentage rates that compares the total net benefits, the returns received from a project to the total cost, the investment of the project. In simple terms, so what it does, it tries to look at the percentage of the benefits obtained over the total cost of the project. And net present value, that means the total value of the benefits minus the total value of the costs. So once you subtract those two amounts, you get the net present value, and we will be performing all this 2 weeks from now. By the way, all these things will be tested in a final exam. Now, cost benefit analysis checklist. So when you are doing a cost benefit analysis, that means you want to see what all are your costs and what all are your benefits, and then analyze and compare. So you will have a look at these things. So list each development strategy being considered. Identify all costs and benefits for each alternative. Consider future growth and the need for scalability. Include support costs for hardware and software. Analyze various software licensing options. Apply the financial analysis tools to each alternative. Study the results and prepare a report. So when you are performing a cost benefit analysis, what you're doing is you'll have options, let's say 1, 2, 3 options. So what you'll do is you'll list down all the options and then start putting in all the relating costs, all the relating benefits. Now, you're not only relating it for the current day, but you're also relating it to the future as well. Moreover, you'll also look at what are the costs of the support for each and every hardware and software that you're using. Now, sometimes when you use hardware and software, you purchase the software, and after a few years, you have to pay for the licensing as well. So all these things need to be considered. And these are very minor things, but they add value or they cost an organization a certain amount of money. So software acquisition process, step 1, evaluate the information system requirements. That means you go around, dig out all the requirements that is needed by the organization. Identify key features, consider network and web related issues, estimate volume and future growth, specify hardware, software, or personal constraints, okay? And you prepare a request for proposal or quotation. Now, this is where I want you to put your concentration is request for proposal. Describes the company's lists the IT services or products needed and specifies the features requirement. So request for proposal, what happens is that the system analysis will go and list down all the hardware, software, IT services or products that is needed by the organization to actually build the software. That's request for proposal. A request for quotation is more specific than a request for proposal. So the difference between those two is as such. So when you are making a request for proposal, you're just listing down all the hardware, software, all the services, support, and products that you need. When you're making a quotation or request for quotation, you are not only listing down all the hardware, software, services, and products, but you're listing them how many or what type of hardware, what will be the cost, what would be the time in which it needs to be taken off and new will be coming in. Okay, so if I would say I need laptops, how many laptops, what is the cost of that laptop, is there any discounts given if you buy this amount and that amount, and so forth. Okay, so online order processing estimated. Okay, you can have a look at this. Now when I actually started preparing this slide, I thought not to remove this but keep it. Why? Because this is something that might be beneficial for you for your major project. Remember your major project? Okay, probably you can use something like this, okay, and see how it goes. Now what does is this table shows what is the current system like and what would be the new system like. Okay, so look at this, the current level. So this is the current level. So feature growth based on existing procedures. So with the current system, if there's a growth, this would be the growth like. Now look at the current level, and assuming that the website is operational. So your growth increases to that much. Okay. So this is more likely something that you can cross compare while evaluating the system. Now have a look at this. Top, the one that you see on top, that's like a request for proposal. Okay, so the price of a specific item is listed. Okay, so vendor A would perform certain types of work, and that is the rating that is given. Okay, from 0 to 10. Now, if you look at the bottom, that's a request for quotation. So you have the vendor, but they are in detail. Okay, look at the weight factor is 25. So the rating was 6, so 6 multiplied by 25 gives you a value of 150. Now, what we'll do is we'll have a look at this when you actually perform the calculations. Okay, but you can use something similar in your major project as well. Go over it and see if you can actually implement it. If you cannot implement it, that's all right, but see if it actually matches with the project that you're doing. Step 2. Step 1 was you identifying your requirements. Okay. Step 2 is you identifying potential vendors. The internet now, so how do you go around looking at the vendors or possible outsource options? The internet contains information on all major products and acquisition services. The organization can avail the services of a consulting firm that help companies select software packages. Online forums or news groups provide opinions and ideas. You have Google groups or Yahoo groups. Now, if you're looking for potential vendors, now you can always do a Google search. Let's say you found a company and now you want to see whether this company is legit or not, whether this company provides quality services or not. You can always go and look at the reviews. There are many organizations running online that runs a website which just does review of the products. So if that is doing well, why not go and have a look at it? Step 3, evaluate alternatives. So you have, let's say, 3 different vendors. So what you can do is you can always go and evaluate. Now, how do you evaluate first? You can always go and look at the existing users, provide feedback about the experiences. So this comes in terms of the reviews. Application testing. So what you can do is you can always go and test applications yourself and see whether it meets your needs or wants or not. And the other one is benchmarking. Measures the time a package takes to process a certain number of transactions. Each package is matched against requests for proposal features and the choices are ranked, just like the table that you've done. Step 4, perform cost-benefit analysis. So once you have selected your alternatives, or once you're evaluating alternatives, what you are supposed to do next is perform a CBA, cost-benefit analysis. So in CBA, you identify and calculate total cost of ownership for each option being considered. So you'll see what is the amount of expenses and what is the amount of benefit that comes through. What is the amount of profits that you're able to derive through. Okay, and study the conditions of use that come along with the software license. If a software package is purchased, consider a supplement maintenance agreement. Don't worry about those at the moment. Step 5. So after you have evaluated, you perform the cost benefit analysis. So you'll have a list of vendors and you'll see how much would it cost you, what is the benefit, how much time, and what all services do these vendors provide. So from here, you'll make a recommendation. So evaluate and describe alternatives along with cost, benefit, advantages, disadvantages, and submit a formal system requirements document and deliver a presentation. So this is normally the work of a system analyst. So system analysis does all this work for the organization and presents the results. Now implement the solution. Implementation tasks will depend on the solution selected. Before the new software becomes operational, complete all implementation steps: loading, configuring and testing the software, training users, converting data files to the new system's format. Now, these are some of the things that needs to be done. When we talk about loading is talking about installing, okay, configuring and testing the software, and then you have to go around and train the users so that they are well versed and they adapt to the software very, very easily. And then finally, you have to convert data files to the new system's format. If the data file formats remain the same, that's good. If not, it needs to be converted. Now, how do they convert? Probably they might use a software. Probably the current new system that will be implemented within the organization would allow it to allow the conversion to take place by its own. Completion of system analysis tasks. System requirements document called software requirements specification contains the requirements for the new system, describes the alternatives considered, makes a specific recommendation to the management, similar to a contract, identifies items that system developers must deliver to the users, format and organize the system documents, easy to read and use. So these are all the work that needs to be done in the system analysis phase. Okay, so once you are working on your own project as well, okay, if it talks about you performing a system analysis, please consider slide number 36 of your week 9 lecture. This would be very much beneficial to you. Okay, and the last thing that finishes up is with the presentation to the management. So what do you present? Helps take key decisions that affect the future development of the system. Suggestions for effective presentations. So in the presentation, you start with a brief overview. You start with why the project is needed, or why the software is needed, what is the purpose of the software. You summarize the primary viable alternatives. That means you have the alternatives, the different types of vendors, let's say vendor A, B, and C, and then you go and summarize the qualities or the services that each and every vendor is providing. Then explain why the evaluation and selection team chose the recommended alternative. So you have to give reasons why. So your reasons would basically depend on total cost of ownership, the conditions probably, and moreover the benefits, the net profit value that derives afterwards. And then allow time for discussion, obtain a final decision from management, or agree on a timetable for the next step in the process. So once, let's say, the organization agrees, they'll discuss probably, sometimes they may take days to actually come up with a solution or several meetings. So once the discussion portion is done, they come to a decision whether to agree or disagree. If they agree, that means you move on to system design from here. This is system analysis, by the way. If they agree, you move on to system design. If they don't agree, they will tell you why, and most likely you'll need to go and redo the entire work and come up with a solution as per their expectations. Now, depending on management's decision, a system analysis will do one of the following: implement an outsourcing alternative, develop an in-house system, purchase or customize a software package, perform additional system analysis work, or the last option and the worst option is stop all future work, further work. So if all further work is stopped, okay, that means software handling portion or the software development phase finishes. That means you might need to wait for some time to get a new software implemented within the organization. Post presentation and management decision, the project begins a transition to the system phase to SDLC. That means the designing phase. Transitioning to system design, preparing for system design. System design requires accurate documentation, provide detailed specifications for output, input, data, processes, and other requirements. Logical and physical design. So logical design defines what must take place. So the logical design is basically you coming up with a paper-based or a software-based design, or what all the system is supposed to do, or how data flows within the organization. Physical design describes the actual process of entering, verifying, and storing data. So your physical design may be in form of a prototype. Logical and physical designs are closely related. Accurate system analysis is required. Now, why they are closely related? Because the logical design describes how data flows within the system. Whereas physical design, it will show how will data flow, but it's the actual physical system in a smaller way, a smaller version of the actual system. So in that case, both of them are very closely related. And then only if your system analysis was done in a very accurate method, then your system design would be able to, will take place very, very effectively. So chapter summary. A new trend views software as a service, SaaS, rather than a product. Traditional systems must function in various hardware and software environments, be compatible with legacy systems, operate within the constraints of company networks and desktop computing capability. Companies that choose to handle their own software development needs can create in-house systems, commercially purchase software packages. So that's the description of traditional based systems. And if you are choosing to have a traditional based system in terms of a software development done within the organization, you can choose building it in-house, or what you can do is you can commercially purchase the software. Okay. Now, the system analysis role in the software development process depends on the specific development strategy. The most important factor in choosing a development strategy is the total cost of ownership. That means, what is the total cost? What is the total benefits? And see whether the benefits outweigh the total cost or not. If it outweighs, that means you are choosing a good strategy. If it does not outweigh, that means the cost is more than the benefits, that means something is wrong somewhere. Now, to actually calculate the total cost of ownership, you will use some form of financial analysis tools. And these are payback analysis, return on investment, and net present value. Now, all these calculations, like I mentioned, we'll be doing it within 2 weeks' time. Acquiring software involves a series of specific steps. Now, those steps we have discussed, from moving from system analysis to system design. The system requirements document is a deliverable or end product of the system analysis phase. So once your system requirement document is approved, only then you can move on to the next phase. Else, you might need to rework on it or reanalyze or stop the software development process. And that finishes up your lecture slides for week 9. Any questions or any queries, anyone? Now, let me just make it clear out there. Now, this is quite interesting in one way, but also this is a lot of information. So you might need to go back and read this properly and understand them. Now, I will give you a heads up. A lot of questions generally is asked in the final exams from this set of slides. Why? Because there's a lot of things. Now have a look at this. And I want you to note this down, okay? If you look at slide number 4, so over here is talking about the traditional and the new way of software development, okay? So questions can be asked based on this. You need to know the definition of SaaS, software as a service, and what it is. Also, a comparison between the traditional software development and the web-based systems. You should also know what is outsourcing and the issues and the concerns related to outsourcing. That is slide number 10 onwards. And finally, you should be able to compare the reasons for in-house development and some of the features in them, and the reasons for purchasing a software package and the reasons for them, and also learn the reasons for having a cloud-based software system and all the concerns, issues, and explanations on it. Learn about them as well. So these things are very much compared in exams. All right. So this is where I conclude the lecture for today. Is there any questions or any queries from anyone? Any questions, any queries? Last call. No, if there are any questions or any queries, thank you very much everyone for joining in for today's class. And I hope you had a good, well-deserved break. Okay, and you're ready to kick off things with a bang. Okay, also please start working on your projects. It's due within 31 days time, as you counted. 41 days time. It's due within 41 days time. So please ensure that you're attempting all of please ensure that you're working hard for your major project and you're submitting it well before time. Your mid-semester exam marks are already on your gradebook. Do feel free to review them. And also, if you have any questions or queries in regards to it, you can let me know. Otherwise, this is all that I have for today. So I'll see you all on Thursday. We'll be discussing our tutorials on Thursday and also going over use case diagrams. Till then, take care, stay safe, see you on Thursday. Thank you, everyone. Goodbye.